In this section, we'll study about stationary waves and organ pipes. Organ pipes, I hope all of you know, these are hollow glass tubes used to demonstrate longitudinal stationary waves. In general, let us first discuss what the types of organ pipes. In general, we can say there are two types of organ pipes which are generally used in laboratory practice. Very first is closed organ pipe. This is a one which is a hollow glass tube which is closed at one end and open at one end. At one end it is open and other end is closed. And at the open end, say if we bring a source of oscillation, say we bring a tuning fork here which is oscillating, then longitudinal waves will enter in the length of the organ pipe, will reach the closed end and reflected. And here we can say as the end is closed, this will behave as a denser medium because wave cannot move out. So here reflection is an opposite phase, which we already discussed that whenever a wave is reflected from the boundary of a denser medium, it is reflected in opposite phase. So incident and reflected waves superpose in opposite phase. So here destructive interference takes place. Destructive interference occur. So when incident and reflected waves superpose on all the medium particles, stationary waves may get established where we consider at closed end a node should be produced, and at open end as oscillating source is there, as well as when the wave from inside comes and reflected from the air, which is a rarer medium. So it is reflected in same phase. So at open end we can say an antinode is produced. So for formation of stationary waves, the wavelength should be adjusted inside the pipe in such a way that at closed end a node should be there and at the open end antinode should be there, otherwise the wave will damp out. Similar to closed organ pipe, the another type of pipe is open organ pipe. And in open pipe the only difference is it is open at both the ends. There is again a hollow tube which is open at both the ends. So obviously the difference in this is if a source of oscillation is brought close to one end, due to its oscillation longitudinal wave propagates, and when the wave will reach the other end, due to oscillation of medium particles, the particle will scatter outside and this medium becomes rarer, and from the rarer medium the wave is reflected back in same phase. As we know, whenever reflection of a wave takes place from a rarer medium, it is in same phase. So at this point constructive interference occur, and obviously in case of constructive interference an antinode is obtained. Similarly at this open end also an antinode is obtained. So at a particular frequency stationary waves are established due to superposition of incident and reflected waves in the open organ pipe when at both of the open ends antinode is there. At all other wavelengths the wave will damp out. Let's discuss the cases of stationary wave establishment and resonating conditions in closed organ pipe and open organ pipe independently one by one.